Namaste students. I welcome you all to this lecture series of GTU Engineering Physics for the hard branch students. We are discussing module number 3, ultrasonic and non-destructive testing. This is lecture number 3, in which we are going to discuss about the production of ultrasonic waves. In the second part of that is the production with the help of piezoelectric generator. So today we are going to discuss about piezoelectric effect and piezoelectric generator. First of all, let us understand what is piezoelectric effect so that we can be aware about the piezoelectricity and the basic phenomena which are used in the piezoelectric generator. To give title, the first thing which we want to understand is the piezoelectric effect. So first thing is piezoelectric effect. So write down with me what is piezoelectric effect, and then we will discuss about this effect in detail. So this is the piezoelectric effect. Write down with me, it is very important. When pressure when pressure is applied to when the pressure is applied to one pair of one pair of opposite faces opposite faces of crystal crystal like like quartz quartz tourmaline tourmaline rochelle salt, etc. These are a few metals which shows the piezoelectric effect, few materials which shows the piezoelectric effect, etc. cut cut with their faces cut with their faces perpendicular to perpendicular to perpendicular to optic axis optic axis equal, this is important, equal and opposite charges equal and opposite charges appear across it appear appear across it. This effect is known as piezoelectric effect piezoelectric effect. And further to add in this, the materials which shows which shows piezoelectric effect piezoelectric effect are called are called piezoelectric material piezoelectric material. And and the electricity, because the charges are generated, we can say that the electricity is generated. The electricity generated generated by this way by this way is known as piezoelectricity piezoelectricity electricity. So this is the basic definition, or we can say that understanding about the piezoelectric effect. So let us see once again. When a pressure is applied to one pair of opposite faces of a crystal like quartz, tourmaline, Rochelle salt, etc., cut with their faces perpendicular to optic axis, this is important, the opposite charges appear across the faces, which is known as the piezoelectric effect. The materials are known as piezoelectric material, and the electricity or charges which is generated by this way is known as piezoelectricity. તો ગુજરાતીમાં સમજાવું. આપણે અમુક પદાર્થો છે જેમ કે ક્વાર્ટઝ બહુ પ્રચલિત છે, ટુર્મેલિન તમે ધ્રુવીભવન વખતે ભણી ગયા, ટુર્મેલિન પ્લેટ અને એના ઉપયોગો. એ પ્રકારના પદાર્થોને આપણે બે સામસામેની બાજુ પર જો પ્રેશર આપીએ તો એવું જોવા મળે છે કે એની ઓપોઝિટ ચાર્જ, એની ઓપોઝિટ સાઈડ જે છે એના પર ઇક્વલ એટલે કે સમાન મૂલ્યના અને વિજાતીય પ્રકારના વિદ્યુત ભારો જોવા મળે છે. આ જે ઘટના છે, આપણે પ્રેશર આપીએ છીએ અને વિદ્યુત ભાર જોવા મળે, એને પાઇઝો ઇલેક્ટ્રિક ઇફેક્ટ કહેવાય. અને આવા જે બધા મટીરિયલ છે એને પાઇઝો ઇલેક્ટ્રિક મટીરિયલ, અને આ રીતે જે વિદ્યુત ઉત્પન્ન થાય એને આપણે નામ આપ્યું છે પાઇઝો ઇલેક્ટ્રિસિટી. તો આ પાઇઝો ઇલેક્ટ્રિક ઇફેક્ટની બેઝિક અન્ડરસ્ટેન્ડિંગ છે. નાઉ લેટ મી એક્સપ્લેન યુ the phenomena in detail. See, as if you remember that we uh, draw tourmaline plate like this. તો એનાથી તમને જે જૂનું છે એ જ સમજાય એટલે હું આમ જ દોરું છું. This is optic axis. This is optic axis. ગુજરાતીમાં આપણે એને દગ અક્ષ કહીએ છીએ. આ તમને યાદ આવે એટલા માટે તમારે યાદ તો optic axis જ રાખવાનું છે. So this is optic axis. Now this effect shows that if we apply pressure to the opposite faces of the crystal. So this is how we apply pressure. So this is pressure we apply on the both side. અહીંયાથી પણ આપણે આમ pressure આપીએ છીએ, અહીંથી પણ pressure આપીએ છીએ. As a result of this pressure, it is observed that the negative charge, let us say, is appear across this face, then the equal amount of positive charge appear on the opposite faces. So when the pressure is applied to two opposite faces of a crystal like quartz, we get the charges across the another two faces. So this is, let us say, plus q charge, and this is, let us say, minus q charge. So we get the electricity through the mechanical pressure. So this piezoelectric effect, this is very important, or piezoelectricity, this effect converts mechanical energy. See, we apply the pressure, mechanical energy mechanical energy into the electrical energy. So this is the main advantage of piezoelectric effect. You will learn more about piezoelectric material, how the piezoelectricity is used. So many advanced technologies are available which explain the piezoelectric effect, but this is the uh, electric version of magnetostriction effect. See what happened in magnetostriction effect, that we put the ferromagnetic rod in alternating magnetic field, then we get the vibration of rod. Here what happen, if we apply pressure to this thing, then we get the electricity. Now if we change this thing, suppose pressure is converted to compression, it means that if we compress this, તો આવી રીતે જો એપ્લાય કરીએ ઊંધી ડિરેક્શનમાં, so it is known as compression. So or we can say that rather to compression stretch એ વધારે proper રહેશે. Stretch તો થતું નથી, but if we apply the force in opposite direction, then the polarity of charge changes. Then the polarity of charge changes. Polarity of charge changes. It means that when we apply pressure, suppose this plate or this side is negatively charged, and this side is positively charged, then when we stretch or change the direction, this will become positive q and this will become negative q. So if we change this thing, we apply pressure, stretch it, pressure, stretch it, pressure, stretch it, then the equivalent opposite charges are or charges are changing across these two faces. So we get the alternating charges, and by means of that we can get the alternating current. એટલે જુઓ આ ટુર્મેલિન પ્લેટ જે આપણે દોરેલી છે એના જેવું એક સ્ટ્રક્ચર છે. ટુર્મેલિન પ્લેટની આ દગ અક્ષ આપણે એને કહીએ છીએ. તો એમાં જો આપણે પ્રેશર એપ્લાય કરીએ જે પાઇઝો ઇલેક્ટ્રિક ઇફેક્ટ કે છે એ રીતે, તો એક બાજુ ઋણ વિદ્યુત ભારો પ્રેરિત થાય અને બીજી બાજુ ધન વિદ્યુત ભારો મળે. એટલે આમાં જે મિકેનિકલ એનર્જી છે એને આપણે કન્વર્ટ કરીએ છીએ ઇલેક્ટ્રિકલ એનર્જીમાં. એટલે મિકેનિકલ એનર્જી માંથી ઇલેક્ટ્રિકલ એનર્જી મળે. બીજું આપણને એ પણ જોવા મળે છે કે જો આપણે પ્રેશર એપ્લાય કરવાની બદલે એને ખેંચીએ અથવા તો વિરુદ્ધ દિશામાં આ પ્રેશરને રાખીએ, તો જ્યાં ઋણ વિદ્યુત ભારો હતા ત્યાં ધન અને ધન વિદ્યુત ભારો હતા ત્યાં ઋણ વિદ્યુત ભારો મળે છે. એટલે જો આપણે ફોર્સની ડાયરેક્શન ઉલટાવી નાખીએ તો પોલારિટી પણ ઉલટાઈ જાય છે. એનો મતલબ કે આપણે જો કમ્પ્રેસ સ્ટ્રેચ કર્યા કરીએ તો આ પોલારિટી છે એ બદલાયા કરે અને આપણને ઓલ્ટરનેટિંગ ચાર્જ અને જેના પરિણામ સ્વરૂપ આપણને ઓલ્ટરનેટિંગ ઇલેક્ટ્રિસિટી તમને આમાંથી મળશે. સો ધીસ ઇઝ અબાઉટ ધી piezoelectric effect. Okay. Now let us discuss the principle of piezoelectric generator. Now we are aware about the piezoelectric effect. So let us discuss about principle of piezoelectric generator, and that principle is nothing but inverse piezoelectric effect. Inverse piezoelectric effect. So it is exactly opposite to the piezoelectric effect. Now let us discuss that also. So write down with me. If if an alternating if an alternating voltage voltage or rather we can say that charges, alternating voltage applied is applied to one pair of opposite one pair of opposite faces of crystal alternatively 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 mechanical contraction and expansion and expansion contraction and expansions are produced are contractions and expansions are produced in the crystal and and crystal crystal starts crystal starts vibrating starts vibrating. This phenomena is is known as is known as inverse piezoelectric effect is known as the inverse piezoelectric effect, or it is also known as electrostriction effect. electrostriction effect. So this is about the definition of inverse piezoelectric effect, or we can say that the principle of piezoelectric generator. Now see, let us read it once again. If an alternating voltage or charges is applied to one pair of opposite faces of crystal like quartz, tourmaline, etc., alternatively we get the mechanical contraction. Now you know that contraction એટલે સંકોચન, expansion એટલે વિસ્તરણ. એટલે મેં ગુજરાતીમાં અત્યારે લખ્યું નથી. So mechanical contraction expansions are produced in the crystal, and therefore crystal starts vibrating. This phenomena of vibration of crystal by means of applying alternating voltage or charges is known as the inverse piezoelectric effect, or it is known as electrostriction effect. So it is exactly opposite to the piezoelectric effect. Suppose this is the crystal, sorry, this is the crystal, piezoelectric crystal. This is its optic axis, and it implies that if we change the positive and negative charges over here, suppose at this instant this is plus q and this is minus q, and if we suddenly changes this, so we alternate the charges across two faces, then it indicates that we get the mechanical expansion and contraction of the crystal. Suppose during this, if this is in the stretch situation, then if we change the polarity, suppose minus q here and plus q here, then we get the pressure across the side. So by changing plus q minus q plus q minus q across these two faces, we get the alternating vibration of the crystal, which is known as the inverse piezoelectric effect, or it is similar to the magnetostriction effect, but here we are changing alternating electric field or alternating voltage or alternating charges, so it is known as the electrostriction effect. So this is the basic working principle of the piezoelectric generator, is the piezoelectric effect. Now let us understand the construction of piezoelectric generator. So this is here the construction or circuit diagram of piezoelectric generator construction. Then after we will discuss about the working also. So, this is the circuit diagram of piezoelectric generator or piezoelectric crystal. Let me draw this diagram once again. As you remember that we draw the same, we explain the same thing in the piezoelectric generator also. There is a ready circuit, and we draw it once again so that that part must be clear to you. Now see, here this is the quartz crystal Q is written here, and it is placed between two plates A and B, two metallic plates. We cannot say it complete capacitor, but it is just like a plate of capacitor. બે મોટી પ્લેટ હોય ધાતુની, એના વચ્ચે આપણે આ ક્વાર્ટઝ ક્રિસ્ટલને રાખ્યો છે. એની સાથે ટ્રાન્સફોર્મરનું સેકન્ડરી લગાડીએ એટલે પોઝિટિવ નેગેટિવ થયા કરે, અને ક્રિસ્ટલ જે છે એના વાઇબ્રેશન થયા કરે. So let us draw that thing first. So here is the crystal. These are two metal plates. One plate is here, another plate is here, and it is connected with the secondary coil. It is connected with the secondary coil of transformer. So this is the coil, secondary coil of the transformer, and we put we put a quartz crystal. This is the quartz crystal Q, and which is placed between the two plates A and B of metal. Some at some instant, let us say this plate is positively charged and this plate is equally negatively charged. This is the first part. Now in the primary, this is the secondary coil S. Now in the primary there are two coils. So let me draw that coils here. This is first coil and here is the second coil. Here is the second coil. In between there is a core material which is indicated by this type of lines. So these are the indication of core. And this coil is, let us say, L1, and this coil is, let us say, L2, and this coil is, let us say, L3, and this is the primary coil P. So we can say that this is the primary coil P. Now with the L1 we connect a capacitor C1. So there is the LC oscillatory circuit, as we know that the oscillatory system is required for the production of any type of waves. So this forms, we can write like this. This is this is the LC oscillatory oscillatory or tank circuit which has a frequency which is equal to 1 upon 2 pi under root L1 C1. So charge is oscillating between the plates with this frequency 1 upon 2 pi into under root L1 C1. So this is the capacitor circuit. Now this circuit, LC circuit, is connected between the base and emitter of a transistor. So here I draw a transistor circuit. This is a transistor. It is drawn like this. This is base, this is collector, and this is emitter. So let me draw the terminals base. This is the collector C, and this is the emitter E. So between base and emitter we connect the LC oscillatory circuit. So this is one end and this is the second end. So between base and emitter of a transistor, LC oscillatory circuit is connected, and between collector and emitter, L2 is connected and via battery. So here is the second circuit which is connected between collector and emitter through a battery. So this is a battery which is variable one and it is connected through this. So this is a battery, BATTERY battery. So this is all about the piezoelectric generator. Let me revise the circuit once again so that it will be clear. It is slightly complicated than the magnetostriction one, but the basic working principle is the same. Across the transistor we connect LC circuit and a coil and a battery. There we have opportunity to wind it over the magnetostriction road, that is over the ferromagnetic road. Here it is not possible as the crystal is separate. So we have to use two coils L1 and L2 which are mutually connected. So we can write like this also. These two coils L1 and L2 and L2 are mutually connected mutually connected mutually connected with each other, so that they can use for the feedback of the circuit. And after the vibration we get the ultrasonic waves across the quartz axis of the quartz or optic axis. So these are the ultrasonic waves. These are the ultrasonic waves. So let me explain it once again. You have to remember 3 points. First point, a quartz crystal is placed between two metal plates A and B which are connected with the secondary coil of a transformer. ફરીથી કહું છું, ક્વાર્ટઝ ક્રિસ્ટલને ધાતુની બે પ્લેટ્સ A અને B ની સાથે ટ્રાન્સફોર્મરની સેકન્ડરી કોઇલ સાથે રાખેલો છે. This is first thing. Second point, the L1C1 oscillatory circuit is connected with the base and emitter of a ટ્રાન્ઝિસ્ટર. તો ટ્રાન્ઝિસ્ટરના બેઝ અને એમિટર સાથે L1C1 દોલક પરિપથ જે છે LC દોલક પરિપથ એને રાખેલો છે. And another coil L2 is used as a feedback loop which is connected between collector and emitter of a transistor via battery. તો બીજી જે L2 છે એ લૂપનો ઉપયોગ આપણે ફીડબેક માટે કરીએ છીએ જે ટ્રાન્ઝિસ્ટરના કલેક્ટર એમિટર વચ્ચે રાખેલી છે અને એની સાથે એક બેટરી પણ જોડેલી છે. So there are 3 points. One is about quartz crystal, second is about LC circuit, and third is about L2. So this is all about the construction of piezoelectric generator. Now let me explain you the working of this circuit. So next is working of piezoelectric generator. So working is nearly same as we discussed in the magnetostriction one, but here we have to write that not ferromagnetic rod is oscillating, but here the quartz crystal is oscillating with some frequency. So first, after switching off the circuit with the help of battery, now see, this is, suppose this plate is negatively charged and this plate is positively charged at a given instant. So this charge is passing through coil L1 and collected by the down plate of this C1. So negative plate becomes positively charged. So charges are starts to oscillate between the plates of capacitor C1. So after half of the time period, all the charges are accumulated from top plate to bottom plate and vice versa. પછી અહીંથી આમ જશે. So the charges are vibrating across these two plates like this. So this type of vibration starts uh, uh, between L1 and C1. So after after switch on switch switching on the charges starts vibrating the charges start vibrating across the plates of capacitor C1 which produces the waves of frequency f is equal to 1 upon 2 pi under root L1 C1. So this is the first thing. Now as as the polarity as the polarity of the plates AB plates and B so this polarity of plates A and B continuously changes the quartz crystal which is indicated by Q in the figure starts starts vibrating due to due to inverse piezoelectric piezoelectric effect. So this crystal starts vibrating with the inverse piezoelectric effect, hence produces ultrasonic waves sorry, vibrate with the to inverse piezoelectric effect. The frequency of vibration of crystal is given by f is equal to 1 upon 2l under root y by rho 1 upon 2l under root y by rho, where L is thickness of crystal. Thickness of crystal. See, remember that it is thickness of crystal. So in some textbook they write T there. અહીંયા છે T લખેલું હોય તો પણ એ આપણે magnetostriction સાથે સરખું રાખવા L લખ્યું છે, but you have to remember that L is the thickness of crystal, and as we know that Y is Young's modulus. Young's modulus of quartz or tourmaline or any other material which is used here, and rho is density of the material. Density of the material. So this is, let us say, equation number 1, and this is, let us say, equation number 2. So at the time of resonance, at the time of resonance, the the ultrasonic waves generated along the optic axis, along the optic axis as shown in the figure. As shown in the figure, see here, this is the optic axis, this is the optic axis, and the ultrasonic waves are generated when the resonance condition is achieved. So the resonance condition is this, that 1 upon 2 pi under root L1 C1 is matches with this frequency 1 upon 2L under root Y by rho. This is the frequency matching circuit. At this time, the waves with maximum amplitude is generated as it is the resonance condition, and at that time we get the ultrasonic waves along the optic axis. So આમાં પણ બે વસ્તુ તમારે યાદ રાખવાની છે. પહેલું એલસી દોલક પરિપથ જે છે એની ફ્રીક્વન્સી જે છે એ આટલી છે 1/2 પાઈ L1 C1 જેટલી, અને જેવું એ બી પરની પોલારિટી ચેન્જ થશે, એ બી પરના વિદ્યુતભારો ચેન્જ થશે, એ પ્રમાણે જે ક્રિસ્ટલ અહીંયા દેખાડ્યો છે એના વાઇબ્રેશન શરૂ થશે, અને જેવો ક્રિસ્ટલ વાઇબ્રેટ કરવાનું શરૂ કરે એની વાઇબ્રેશનની ફ્રીક્વન્સી છે એ આટલી હશે. એમાં એલ જે છે ખાસ યાદ રાખજો, જે ક્રિસ્ટલ લીધો છે એની જાડાઈ છે, વાય યંગ્સ મોડ્યુલસ, અને ડી રો ડેન્સિટી જે આપણે ગયા વખતે જોયું હતું તેમજ. તો જ્યારે આ પરિપથની આવૃત્તિ અને આની આવૃત્તિ, બે વાઇબ્રેશનની આવૃત્તિ બે સરખી થાય એને આપણે રેઝોનન્સ કન્ડિશન કહીએ છીએ. તો રેઝોનન્સ વખતે એ બે આવૃત્તિઓ છે એ સમાન થાય, અને એ વખતે ઓપ્ટિક એક્સિસ ને સમાંતર તમને અલ્ટ્રાસોનિક તરંગો જે છે એ ઉત્પન્ન થયેલા જોવા મળશે. So this is about the working of ultrasonic waves by the method of piezoelectric generator. And now let us discuss about the advantages and disadvantages. So here I write merits of this generator, and here I write the demerits of the generator. Now you know that merits and demerits are advantages and disadvantages respectively. So let us write that once again. Merits, it is clear that it is more efficient. It is more efficient than magnetostriction generator. As it gives more power and more energetic waves, and due to this almost all the generators used are of this type. So majority generators, suppose we use this generator in sonography machine, then we use piezoelectric generator rather than the magnetostriction generator as it gives more energetic waves, and the penetration power is also high for the waves which are generated by the piezoelectric waves. See, the limitation of magnetostriction is overcome by this ultrasonic frequency as high as 5 into 10 raised to 8 hertz, that is almost 500 megahertz. 500 megahertz obtained can be obtained with this arrangement, with this generator. So this generator generates the very high frequency ultrasonic waves, and it is not affected by temperature. As we know that the ferromagnetic materials are highly dependent upon the temperature and humidity and humidity. So there is no effect of weather on the frequency which is generated by the piezoelectric crystal. So that is one of the major advantage of the piezoelectric generator. Now demerits are very common and it is practical. The cost, the cost of piezoelectric quartz, piezoelectric quartz is very high, is very high. So, as we know that the quartz are not easily available, the tourmaline material is also not as easily available as the magnetic one. આપણે magnetostriction માં એવું જોયું હતું કે magnetostriction માં ferromagnetic material વપરાય તો easily available છે, but quartz is not easily available material or available earth element. So the cost of piezoelectric itself is very high, therefore it is very costly generator. And the cutting, the cutting and shaping and shaping of crystal of piezoelectric crystal, piezoelectric crystal are very complex. See, આપણે હીરા ઘસીએ છીએ અને જેવું થાય એવું જ કામ આમાં થાય છે. એટલે એની ઓપ્ટિક એક્સિસ ને પેરેલલ જે આપણે શેપિંગ કરવાનું હોય, ક્વાર્ટઝ છે it is very tough material. So to cut it is very complex. So the process of making the quartz usable, the quartz કે કોઈ પણ piezoelectric material હોય કે જેને આપણે use કરી શકીએ એવા ફોર્મમાં મૂકવું હોય, so it is very difficult, and therefore the cost is also increases. એક તો piezoelectric material easily available જ નથી, મળ્યા પછી પણ એને જે કટ અને શેપ કરવાનો થાય એ પણ બહુ મોંઘું છે. Therefore the generator which is available, which uses the piezoelectric principle, are very costly. That is the only demerits or disadvantage of the generator. And finally, let us discuss what is given in the textbook or in the physics book. So let me read and explain you. This is about the piezoelectric effect. As we know that the principle of the piezoelectric generator is inverse piezoelectric effect. So before understanding of inverse piezoelectric effect, it is necessary or required to understand about the piezoelectric effect. So when the pressure is applied to one pair of opposite faces of crystal like quartz, tourmaline, etc., cut with their faces perpendicular to its optic axis, equal and opposite charges appear across the another faces as shown here. See, this is the equal and opposite charges generated here when we apply pressure to the opposite side. This phenomena is known as the piezoelectric effect, and the frequency of developed EMF is equal to the frequency of dynamical pressure. Whatever pressure we apply to the material, the same frequency charges are appear here also. So this is important. The sign of the charges get reversed if the crystal is subjected to tension instead of pressure. So if we apply this in this opposite direction, if we tense this quartz, then we get here positive charges and here negative charges. So charge polarity reversed. The electricity produced by means of piezoelectric effect is called piezoelectricity, and such materials are known as piezoelectric materials or piezoelectric crystals. So this is about the piezoelectric effect. Now let us discuss the piezoelectric generator. The basic working principle of piezoelectric generator is inverse piezoelectric effect. So let us read that also. If an alternating voltage is applied to one pair of opposite faces of crystal, now here we apply alternating voltage, AC voltage જેને આપણે કહીએ છીએ, to the crystal. Alternatively, mechanical contraction and expansions are produced in the crystal and crystal start vibration. So here by applying electricity electricity, we get the vibration of crystal. Therefore it is known as electrostriction effect. So this is known as inverse piezoelectric effect, or it is known as the electrostriction effect. So this is basic construction circuit diagram of the piezoelectric generator. We will not discuss that as we discussed it above. So there are only three points. First is this, second is this, and third is about this. So this is the same working of piezoelectric generator, in which the first point is when we switch on the circuit, we get the vibration of charge across the base emitter circuit, which is LC circuit, which is connected across the base and emitter, and with this frequency 1 upon 2 pi root L1C1, it starts the vibration. Now as the value of capacitor C1 changes, LC tank circuit frequency also changes, and that changes the flux in coil L3, which is EMF induced the coil, which converts to the polarity across the two plates of A and B. And after it, the vibrating crystal produces the longitudinal ultrasonic waves in the surrounding air, having frequency equal to this. Here, as elastic constant for solid is Young's modulus, so E is equal to Y, and we get the longitudinal ultrasonic waves with frequency 1 upon 2L under root Y by rho. And this is the frequency matching circuit condition, the resonance condition, which we saw in earlier theory also of magnetostriction generator. 1 upon 2 pi under root L1 C1, which is equal to 1 upon 2L Y by rho. And this is the merits and demerits of ultrasonic crystal, uh, which I told you. It is more efficient than magnetostriction. Almost all modern type of ultrasonic generators are of this type only, or it means that the modern generator uses the piezoelectric effect rather than the magnetostriction effect. Ultrasonic frequency as high as 5 into 10 raised to 8 hertz can be obtained with this arrangement. So we can get the ultrasonic waves of frequency 500 megahertz, which is very high as compared to the magnetostriction generator. And the main thing is it is not affected with the temperature and humidity. There is no loss of eddy current and no loss of heat, etc., which we saw in the magnetostriction generator. But the only limitation of this device or this generator is the cost of piezoelectric quartz is very high. Why? Because it is rarely available material, and cutting and shaping of the piezoelectric crystal is very complex, uh, like diamond. We require a skilled technician or skilled workers, so that we can get the cutting and shaping of piezoelectric crystal as per our requirement to generate the ultrasonic waves. So as the cutting and shaping is very complex, very rare manpower is available for that, and due to this, the cost of piezoelectric quartz or piezoelectric generator increases. So better to use magnetostriction for lower frequency ultrasonic waves, and for high frequency ultrasonic waves, we must use the piezoelectric generator. So this is end of second part, which is the production of ultrasonic waves. We saw two electrical generator. One is based on the magnetic effect, which is the magnetostriction generator, and today we saw the electrical version of the generator, which is known as piezoelectric generator. Both are extensively used in the industry and in the scientific purpose also. So this is all about the production. In next lecture, we will discuss about the detection techniques of ultrasonic waves. Thank you very much.